Hi guys, welcome back to my channel. Today I'm going to teach some more questions of titration. Look at that, we have done the titration and I've already explained you what is meant by the term titration. Why we use the titration. This is a physical technique which involves both acid or base, or sometimes we can use a redox type of titration to figure out the concentration of an unknown substance. Yeah, I have already shown you how to make the standard solution. We can make our own standard solution and we will use that standard solution to titrate the unknown substances and work out the concentration of the unknown chemical. So I like this question. Is a type of titration question. Look at that question. I have taken this question from the OCR textbook and I like this question. Is a kind of titration question. So with that, we can work out the MR of the unknown substances, and unknown acid is given to you, and we have to find out MR of this acid. Let's start that question. Look at that. A student dissolve 2.8 gram of an acid, which is unknown. He dissolve in a beaker, like small beaker. He dissolved 2.8 gram and transfer that into a volumetric flask and made a solution up to 250. Okay. After he made a solution, he used only 25 centimeter cube of this solution. Look at that. Solution up to 250. The student titrated 25 centimeter of this acid against sodium carbonate. Okay. So this look like a straightforward titration question. Okay. Now, so the first question is find out the number of moles of sodium carbonate used for this titration. Okay, moles of the sodium carbonate, moles of Na2CO3. Can we work out the moles of sodium carbonate? Yes, guys. Look at that. We have a concentration of the sodium carbonate and we have a volume of the sodium carbonate. Whenever you have a concentration and a volume, the first step is work out the mole. Okay. Mole equals to C times V over 1000, which is 0.05 into 20 divided by 1000. Okay. So that get cancelled. Okay, can I write one more time here because I don't have a space here. So 0.05 times 2 divided by 100. Yeah, when you work out, we will get 0.001 or 1 into 10 to the power of minus 3 moles of sodium, moles of Na2CO3. Now look at that. Can we work out the mole of this acid, guys? Yes, we can work out. Look at the molar ratio. 1:2. So you have to just double it to get the moles of the unknown acid HX. You just double it because 1:2 molar ratio. So moles of HX 2 into 1 into 10 to the power of minus 3. That's nothing but 2 into 10 to the power of minus 3. That's the mole of HCl, HX, my bad, when we use only 25 centimeter cube. But the student made a solution up to 250. So that's the number of moles of an acid HX for only 25 centimeter cube. Can we work out the mole of the acid for 250? Yes, we can work out the mole of the acid for total volume of the acid that the student made, which is 250 centimeter cube. Okay, how can we do it? Just times by 10. This is the mole for 225. So that's the mole for 25 centimeter cube, and we have to work out for 250. So you have to times by 10. Moles of HX for 250. 2 into 10 to the power of minus 3 times by 10, which is nothing but 2 into 10 to the power of minus 2. That's the mole of an unknown acid which is given in the question. So for 250, so 2 into 10 to the power of minus 2 is the mole of an HX. From that mole, can we work out its MR? Yes, we can work out its MR. 2.8 gram of the acid was used by the student to make 250 centimeter cube of the solution. So that's the mole. How can we work out the mole in terms of the mass? Look at that one. Mole equal to mass over MR. So rearrange that formula. So moles equals to, I like this question. That's a nice question, guys. That's a nice question. So mole equals to mass over MR. I want to work out the MR. So rearrange. So MR of an acid HX equals to mass divided by its mole. Mass is 2.8 gram. So 2.8 gram, and that's the mole of an acid. Look at the mole of an acid, which is 2 into 10 to the power of minus 2. Look at that one. Okay. So mass is 2.8 gram divided by 2 into 10 to the power of minus 2. 2.8 is nothing but 1.4 into 10 to the power of 2. Yeah, that 10 to the power of minus 2 goes up. So is equals to 140. That's the MR of an acid, which is HX. Okay. Copy down that one, please. Look at this question. Yeah, it looked very lengthy question. And this is more worded question. It is a simple question, but this is more worded question. Look at that. So a student dissolved 2.10 gram of sodium hydrogen carbonate. He dissolved it in a small beaker. That's 2.101 gram. And transfer that one into the volumetric flask and made a solution up to 250 centimeter cube. And from that 250 centimeter cube, he only used 25 centimeter cube, pipette out, and transfer into the conical flask to start the titration. Before he started his titration, he added methyl orange, which is an indicator, which helps to show the endpoint. I will teach you what is the use of indicator, different types of the indicator in my future video. Now, in the conical flask, he added this sodium hydrogen carbonate, 25 centimeter cube, and added a methyl orange. Now, he titrated this with acid. Which acid? Hydrochloric acid. And he got a tighter volume of 25.9 centimeter cube of acid. What's the question? What we have to figure out? We have to work out the concentration of an acid, hydrochloric acid, in gram per dm cube. We can work out in mole per dm cube than in gram per dm cube. So the first step, how to approach that question, work out the mole of sodium hydrogen carbonate is given. We can easily work out the mole because you have grams. Yeah. So what's the formula to work out the moles? Mole equals to 2.10 divided by 84 23 plus 1 plus 12 plus 48. I think it's 84. So work out the 84. When you divide, so 2.10 divided by 84. 84 is the amount of sodium hydrogen carbonate. When you divide that by, you will get 0.025. That's the mole of sodium hydrogen carbonate. And this is the mole for 250, guys. Why? We made a solution up to 250. Yep. So you have to work out the mole for 25. How can we work out? So you have to divide it by 10. Yeah. Mole of the sodium hydrogen carbonate for 25. So mole of NaHCO3. This is 0.425 equals to 0.025 divided by 10. Why divided by 10? That's the total mole, but we only use 25. So that's the mole of sodium hydrogen carbonate for 25 centimeter cube of the acid. I want to rub this part only. I don't have enough space. Look at that. That's the number of moles of sodium hydrogen carbonate for 25, which is moles of NaHCO3 for 25 equals to 0.00, one more 0.025, guys. Is that okay? 0.0.0225. Okay, that's the mole of sodium hydrogen carbonate for 25. Can we work out the mole of HCl? Yes, you can easily work out the mole of HCl. What's the molar ratio? 1:1. So that's the mole of HCl, because the ratio of HCl and sodium hydrogen carbonate is 1:1. Okay. The moles of HCl equals to, because the molar ratio is 1:1, moles of HCl equals to 0.0025. Okay. And when we neutralized, we got this volume. That's the volume of HCl. Can we work out the concentration of HCl by using this volume? Yes, we can work out. Okay, we can work out the concentration of HCl by using that many moles. What's the formula to work out the conc? Conc equals to concentration equals to mole over volume. How much is the mole? 0.0025 divided by volume, which is 25.9 divided by 1000. Why 1000? I want to change that into centimeter cube into the dm cube. Look at that one. So which is equals to 0.0965 mole per dm cube. Yeah, but that's not the question. The question is calculate the concentration of HCl in gram per dm cube. That's in gram per dm cube. Look, that's the gram per dm cube, and this is mole per dm cube. So how can we change gram per dm cube, mole per dm cube to gram per dm cube? So conc time mR of HCl gives you gram per dm cube. So times this value by mR of HCl. What's the mR of HCl? HCl, hydrogen 1, chlorine 35.5, which is 36.5. So when you work out, so So just I want to rub that one. So Kong time MR, you will get the quantity in gram per dm cube. Look at that. What's the Kong? Kong is 0.0965 times 36.5 equals to 3.25 gram. Okay. Yeah, that's quite a nice question. I want to stop here. You look at that, 0.0965 times 36.5. I've mistakenly written something. So when you do that one, the answer is 3.52 gram dm minus 3. So that's quite interesting question. So we can work out one more question. Yeah. Look at this question. It's a simple, very simple question. You want to try as a homework, or can I try it now? Okay. So look at that one. Sodium carbonate versus HCl. So first of all, I told you a million times, guys, you have to write a balanced chemical equation to start your titration question. First and foremost thing is balanced form of chemical equation when a sodium carbonate react with HCl. So sodium carbonate, Na2CO3 plus hydrochloric acid, we will get sodium chloride plus H2O plus carbon dioxide. Any carbonate when react with acid, we will get salt, water, and carbon dioxide. How many sodium, guys? 2 sodium. How many sodium? 1 sodium times by 2. How many chlorine here? 2 chlorine. So I have to times by 2. Yeah. That's the beauty of the reaction. If you miss the balancing, you can't get the exact number of moles. If you can't get the exact number of moles, then you can't figure out the concentration of the HCl. Okay, that's the equation. That's the first step. Step 2, I told you, write the data in the like a column form or in the tabular form. Like acid, here we have acid and sodium hydrogen carbonate. This is the salt of alkaline solution. Why this is salt of alkaline solution? I will tell you in my future videos. Look at that. Conc, I always told you, use the conc mole wall. Concentration mole wall for both. So concentration of sodium carbonate is given, which is 0.2. Okay. And the volume of the sodium carbonate is given 25 centimeter cube. So work out the mole of the sodium carbonate. Mole easy. Mole C V and mole. Mole equals to some teacher use N. It doesn't matter. You can use N. N or mole equals to C times V over 1000, which is nothing but 0.2 times 25 over 1000, which is nothing but 5 divided by 1000, which is 5 into 10 to the power of 3 mole. Yep. Look at the molar ratio. 1:2. So to get the mole of the HCl, you have to double it. So double that one. 2 into 10, 2 into that, just double the mole. 5 into 10 to the power of minus 3, or 1 into 10 to the power of minus 2. That's the mole of the acid. Which acid we use? Hydrochloric acid. Can we work out the conc? Check whether the volume of the HCl is given. Yes, it is given 20 centimeter cube. Conc equals to N over V. What's N? 1 into 10 to the power of minus 2. Just now we worked it out, divided by 20, divided by 1000. Why 1000? You have to always change centimeter cube to dm cube. So can I rub this part, please? Yes, sometimes we may expect the easy titration question. Don't always expect the titration question in terms of percentage purity. Here, it will come in the examination. So, conc equals to 1 into 10 to the power of minus 2 divided by 20 divided by 1000. So, you can move the 1000 up, which is 1 into 10 to the power of minus 2 times 1000 divided by 20. That cancel. So, this 10 to the power of minus 2 and 100 cancel off. And if you think I confuse you, use the calculator. Best thing, use the calculator. So 1 divided by 2. This 2 0 cancel, that 2 0 cancel. 1 divided by 2 is nothing but 0.5 mole dm minus 3. But that's not the question. The question is that you have to convert the mole dm minus 3 into gram per dm cube. So how can we convert this mole dm minus 3 into the gram per dm cube? Look, conc, concentration time mr equals to gram per dm cube. This is the formula, guys. So remember that formula. Conc time mr. What is the conc? You got the conc. Conc time mr. Yeah. See, one thing, try to memorize all these concepts in the chemistry. Try to learn it. Learning chemistry is fun, guys. When you are trying to memorize the chemistry, it muddle up everything. So learn the concept slowly. I will teach you everything. So hope that will work. Okay, look at that one. So 0.5 time mR of sulfuric acid is 0.5. It's easy to work out the mR of hydrochloric acid. It's easy to work out the mR of hydrochloric acid. 1 plus 35.5. So can you work out what's the answer? So I will leave here. Okay, how much is that? Just half it. It's 18.25. Yep, that's gram per dm cube, guys. Gram dm minus 3. So I want to stop my lesson here. I will come back in my next video with the percentage purity question and the back titration. Okay, guys, thanks for watching this video. Good to see you. Thank you. Bye.